Everybody, and welcome. Coming to you live here with Clover in my lap, so apologies in advance if any dog noises make it through the audio here. But today in our video, we're going to be talking about triangles. So properties of triangles, definitions, how do we write them, how do we look at them, and also how do we do some solving with them. So triangles, huge part of geometry, one of the best shapes out there, very strong shape. You'll see them all the time in things like bridges and other structural supports because they're just so strong and so useful. So we're going to start our unit today looking at all of the properties that make them that strong and that useful. So first things first, triangles, what do we call them? So a couple different ways to name them. You can use the word triangle, and if you do that, you do have to refer to three individual points on the triangle itself, the vertices, the edges of the triangle. So this one would be triangle WXY. The only other way that we can do this is we can actually draw the shape of a triangle and also say WXY next to it. Remember, if you just say WXY, you're referring to a plane, so we have to distinguish. If we just list 3 points out, we have to say triangle or draw the triangle symbol or something, so we know that we're talking about a triangle. Sides of a triangle, there's 3 of them. So we have WX, XY, and WY. So we can label those as such. So if you're asked to identify the 3 sides, you start at one endpoint, go to the other endpoint. As you can see in the 3 colors we have there, those are the 3 different sides. Vertices of a triangle, or the vertex of a triangle, individually are just points. So W, X, and Y. And the key thing to distinguish here is if I were to draw on this point right here, we'll call it point A. Point A is not a vertice. To be a vertice, you do have to be on the edge. So that specificity, it does matter. It makes a difference. So within triangles, we have a few angles as well. And remember, we name angles using the 3 points that make them up. So the 3 angles here is we have X, W, Y. So from X to W to Y, that's our first angle, or right there. We also have WYX. And remember, you're putting that vertex in the center. And then lastly, oh, I got it. So erasing the wrong thing. And then our last one here has X in the center. And if I can erase this correctly, I give up. We can also do W to X to Y as well. So from W to X to Y. So those are the 3 angles that we see inside of a triangle. And again, just a few things that we're looking at here in terms of making up a triangle. So if you're breaking down a triangle into its components, we have its name, we have its sides, we have the vertices, and lastly, we also can look at it using its angles. So there are 3 different types of triangles. The first one is a cute triangle, as opposed to an ugly triangle. Sorry, dad jokes, gotta slip them in if we can. So all angles here are less than 90 degrees. For an obtuse triangle, we have one angle that is greater than 90 degrees. So here we could see that this one is obtuse because that is greater than a corner, bigger than a corner. It's greater than 90 degrees. Lastly, a right triangle has one individual 90-degree angle. So for these 3, we're just basically looking at the biggest angle for right and obtuse, and then for acute, the same thing, the biggest angle does have to be less than 90 degrees. So all 3 of those things together get us to a point where we can classify a triangle based off of its sides. The next one is equiangular, kind of tricky to say out loud. So it's kind of that equal part, so equi and then angle, angular, the 2 parts of it. So triangles are 180 degrees, and they have 3 sides or 3 angles. So if we divide that 180 degrees by 3, an equiangular triangle is one that just has every single angle that's exactly the same. The only way that that's possible is if all 3 of these are 60. So there's no other way to divide 180 into 3 parts that are the same size. So the only way we can do that is if we have 60, 60, and 60. So the next thing we can do is we can look at a triangle by sides. So scalene properties of this one here are all three sides are different lengths. So if we're looking at this, we could say maybe this is 7, this is 5, this is 3. So every side is different. As long as that's true, you have a scalene triangle. Isosceles, the way that I was always told to remember this is you have two eyes. So this just means that two sides are the same. So we'll say this side and this side. We'll use that congruent symbol if you're thinking back on it. So that one dash there on both of those sides means it's the same. So we'll say two sides are equal. And lastly, this time is equilateral. So instead of equiangular, we're talking about equilateral this time. And this would be all three sides are equal. So no sides the same, two sides the same, and then the last one, all three of the sides are the same. So some basic properties of triangles here. One thing I do want to highlight, I know I briefly mentioned this, we also want to make sure we know triangles do have a total of 180 degrees in them. So if you add up all three angles, no matter what, it will be equal to 180 degrees. But other than that, we can just describe them using their side lengths, using some characteristics, and as you can probably imagine, we do get a little bit more into detail here with some of the different things that we'll see. So looking at our practice question here, we are just trying to identify an isosceles triangle. So isosceles triangles have two side lengths that are the same. A couple different options that we can use here, but the easiest way is that we kind of focus in on those little dashes. So if we draw a triangle that has this as a side length and this as a side length, we know that it'll be isosceles, so we just have to connect the dots, and there's only one way to do it, and it would be just like so. So we can say, okay, triangle ABD is an example of that. And I'll actually pause here. There's a second one, so I'll erase all this. A second one with equal dashes that we can do, so see if you can identify that second one. So first, we'll find our equal dashes, so right here and right here. So we want to use those two as side lengths, and we just have to connect the dots. There's only one way to do it, one path in between B and D. So we'll do that right there. So from B to D to E. So triangle B, D, E. So we'll keep going with these classifying questions. So right here, scalene means that all the sides are of different lengths. So again, a bunch of different options here, as long as you don't have any sides that have repeating lengths. So for example, we could say, okay, this is one length, this is a different length, and then connect the dots, boom, A to B to E. So there's one example. A bunch of other different ones here. That's not the only scalene example, but just to show you kind of the process of identifying side lengths, making sure that they're different. And as long as that's true, then you got yourself a nice scalene triangle. For example number 2, we can use some of our properties, and this will be the more common things you'll see on the state test with some calculations. So find x and the measure of each side in the equilateral triangle RST. So equilateral, remember this means all sides are the same. So you actually have a bunch of different options. It doesn't matter what you do as long as you know that one side is equal to the other side. So you can pick any combination. It doesn't matter if you pick the side in yellow, the side in blue, or the side in green. They are all exactly the same. So let's just say we'll pick the yellow and blue because they're on top. Why not? It won't change your answer depending on what you do, so it'll be fine either way. So we want to get all of our like terms together in these situations. So x's go with x's and y's go with y's. Remember, if you're crossing the street, if you're going from one side of the equal sign to the other, you have to make sure you're doing the opposite property to do that. So if we want to take our x right here and we want to move it to the other side to join its friend 2x on the other side of the equal sign, just make sure that we're subtracting x. So we're left with on the left side 9 and on the right side x. So 2x minus 1x is just 1, and 9 just comes straight down. So x equals 9. So we've solved for x, but the question also asks us what is the side length, so we can take 9 and we can plug it into any of these, and it should give us the same answer. So let's say, for instance, we do x plus 9, so we know that x is 9, so 9 plus 9 gets us 18. If we were to plug it in here, 2 times x, well, x again is 9, so 2 times x gets us 18. And just to double check our work here, the green side, this should also work as well, because remember, all of these sides are the same. So 3 times 9 minus 9. So 3 times 9 is 27, minus 9 gets us an answer of 18. So side length is 18, x equals 9. Those are the two different things that this question wants us to solve. And we did it. So again, relying on their properties being equilateral, knowing that we have equal side lengths. Lastly here, we have our JM, MN, and JN of an isosceles triangle. And because we know it's isosceles, they tell us that two sides are equal lengths, and they have to tell us as well, they have to be specific, which sides are equal. If they don't tell us that, we can't assume anything. So we can see in green, JM and MN are the sides that are equal. So based off that, we have to set those two equal to each other, and that's how we're going to solve for x. So I'm going to give us a moment here, see if you can solve this, see what x equals. All right, so 2x minus 5 and 3x minus 9. Remember, if we have like terms on the other side of the street, we have to do the opposite property, opposite operation to move them over. So minus 2x here, minus 2x here. Bring this negative 5 down. 3 minus 2 is just x. Bring our negative 9 down. Again, negative 9 and negative 5, they're both friends. They're just on the wrong side of the street. So we have to bring 9 to the other side of the equal sign. Plus 9 plus 9, so we have 4 over there. 9 minus 5 is 4. And x. So x is just equal to 4. And if we look at this question, it just wants us to solve for x, so that's all we needed to do. And that's what we're going to see here for a lot of our triangle questions is just answer the question, see what it's asking for, and we'll be able to solve. So a lot of the properties, a lot of the definitions we see here on our first page, that's where they're going to be applied to, is setting up equations and getting answers. As always, if you got questions, fire away. We're here to help. Good luck on the practice, and as always, thanks for watching.